Hello everybody, my name is Mridul and I am an alumni of NIT Warangal. So today we will be discussing the topic phasor diagrams or phasor connections of three-phase transformer. Now this particular topic is from electrical machines of electrical engineering for GATE. And this particular topic, which is phasor diagram for three-phase transformer, is very important with respect to GATE. If you see the last 3-year trends of GATE questions from electrical machine, you will see that in every set of the last 3 years, there are questions from this particular topic. So I have chosen this topic from electrical machines. Now before I start with the topic, I will assume that you are clear with the basics of single phase as well as three-phase transformer and the understanding of three-phase. So these are the two prerequisites of this particular topic. That means the basic of transformers as well as the basics of three-phase connection. What is three-phase? Okay. So I will assume that you know that. Now here what we are going to do is, for example, suppose I have three-phase transformer. So when I have a three-phase transformer, I know that there will be primary and secondary. Now my primary can be either star or delta. For example, say I have primary side and I have secondary this side. Okay, so what will happen is, here I can have, say, delta. If I have delta here, my options as delta are, I may have a delta connection here or I may have a star connection here. Okay. Similarly, if I have a star connection here, I may have a delta connection here and star connection in the secondary. Now, what is there to learn in this particular topic? The phase angle or the phase difference or whatever you say, the phase, okay, of a particular vector in primary and secondary will have some difference. Let us say I have three phase here, A, B, C, and I'll also have some phases here. So the phase difference between the phase difference may be of the line voltage or the phase voltage, anything. So say phase voltage of A and of primary and the phase difference between phase A of secondary. Okay, so what is the difference between them? You see, if I have delta connection, there are two possible phase difference, which is 0 degree and 180 degree. In star, if I have a delta star connection, then the possible things are 30 degree lead. That means secondary phasor will lead the primary phasor by 30 degree or it will lag by 30 degree. Similarly, if I have a star connection here and if I have a delta connection here, then it may lead or lag by 30 degree. Similarly, if I have a star and star connection here, since both are same as it was in this case where it was delta, here I will have 0 degree or 180 degree of phase difference between primary and secondary. Now the thing is, how and what type of questions come for GATE. So let us see what type of questions comes in GATE. So the type of questions that you may expect in GATE will be something like that. Say the primary of this is the primary, and as we can see, it is star connected, whereas I have a delta connection here. There are some windings here, here, and here. Now Now this is a 2016 question. I'm taking it as an example to show how are the questions that come for GATE. Now this is small a, this is b, small b, and this is small c. Also, in this particular question, it is this neutral point is given. The dot convention is also mentioned here. As well as in this secondary also, the dot conventions are mentioned in this pattern. So this is a diagram which is given. Now the question that is asked, now this is primary and this is secondary. What is asked is, what will be, there are four options in this particular question. It says that the VAB, which is nothing but the phase EMF which is induced in the primary, and VAB small ab is the, VAB is the line voltage of the primary, and this VAB is the v small a small b is the line voltage in the secondary. Now the questions are VAB leads, VAB, V capital A capital B leads V small b by 60 degree, or leads by 30 degree, or lag by 30 degree, or lag by 60 degree. So there are four. Actually, the question is, you need to find out what is the relationship, phasor relationship of the primary line voltage and secondary line voltage. So that is the question exactly. Another thing is how to do that. So before I go to the solution of this, let us understand how these connections are derived. Okay, so let us understand the connection first, then we will solve this particular question. So you see, as we know that it is a three-phase transformer, that means there will be three sets of, for example, say this is my primary, okay, and say this is my secondary, okay, and let us say this is A and this is A dash, okay, or we name it in any way. Let us say this is A and this is A dash. Similarly, this is small a and this is A small a dash. Now, if in this way the diagram is shown, it means, what does it mean? It means that there is a core, there is a magnetic core of the transformer where in primary, and say this is secondary. So what happens is, this will be my A dash, and this will be my small a dash. So the EMF which is induced, as we all know that EMF will be induced in both primary windings and secondary windings. Now what we are going to see is, what will be the phase difference between the primary and secondary in three-phase transformer. So you see the connections which are possible in this particular three-phase transformer, as we have seen, is delta, star, and delta, delta, star, 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 delta. So let us take an example and see. For example, let us say we have a say star connection in the primary and a delta connection in the secondary. So star connection in the primary means, see, this is B dash, this is B, this is C dash, this is C. So what we will do is, let us say the primary is star connected. That means I have connected this particular end, and I have connected a three-phase source I have connected a three-phase source to these three ends. That means, since I have connected a three-phase source here, so what will happen is three-phase EMFs will be induced in the primary, which is in three phase. That means, we suppose the EMF which is induced in this particular winding, say EAA dash. Okay? E B dash B, E C dash C. Okay, so the EMF induced in this winding, since I have connected this with a three-phase source, will be in three phase. So what I can say is, they will be connected in such a way. And let me say that this is E A dash A, or in other words, now I can say this as EA dash N, EB dash N, EC dash N, because A, B and C are connected and this is nothing but my, say, neutral. Let us say this is a neutral and it is connected to neutral. So, this is my EA dash N, this is my EB dash N, and let us say this is EC dash N. This is how my phasor, which is induced in the secondary looks like. Okay, and these are 120 degree shifted. So the B phase is 120 degree lagging from A phase, and C phase is further 120 degree lagging from B. Okay? Because this happened because I have connected my primary to a three-phase source which is connected in or which is in such a way of three-phase shift. Okay? So now let us see how can I connect my secondary. What is the possible connections of my secondary? So you see, I will rub this primary side and I will draw this particular diagram there. So I will draw this primary side and I will draw the phasor here so that it's easy for me to explain. So now, say this is the case where this end is A dash, this end is B dash, this end is C dash, this is A, this is B, and this is C, and also I can say this point is my neutral point. Okay? Now, what type of connections can I do here? I can do two types of connection. That means either what I can do is I can connect C dash, either I can connect A, B and C, or I can connect A dash, B dash and C dash. So the first thing, that means there are two ways in which I can connect the secondary in star, and so the two ways will be, let me see the first way. Okay, let me see the first connection, which is A, B, C, which is I'll be connecting. So let me connect A, B and C. Now before I connect, I will just draw it in this way, this side. These are my windings, so that we can just follow up from here. This is my A dash, B dash, C dash. Now what I will do is, now this side primary is star connected. Let me connect my secondary also in star, let us say, first case. So what I will do is, first possible connection is, I will connect A, B and C. Let me see what happens. So what I will do, so the first thing you have to understand is, this is, say, the A phase of the transformer, and this is the primary side of the A phase. So the secondary side of this A phase, okay, the EMF, phase EMF will always be it will be in phase. That means you see what will happen. What I'm trying to say is my A dash A will always be, this will be in phase, always. Because, why? Because, see, this is my transformer, as I have already said. Since this is my transformer, so you see, for say I have created this three-phase transformer by joining three different single-phase transformers. Okay, so I have three cores, and each core is representing one phase. So say this is A phase. Okay, here I have connected A and A dash. Now this A dash is nothing but it became my neutral. Okay, now you see the EMF which is induced here in A dash, A and A dash, and in this secondary side A dash will always be in phase. That means this EMF and this EMF will always be in phase. Considering what I am saying is these are the dot convention are in this way. Okay, so if the dot convention are in this way, this will definitely, this A point and this A point and this A dash point and A dash point of primary and secondary will always be in phase. So what I am saying is, without looking at the transformer, I can just draw it in this way, that if my primary capital A dash and this A is in this way, then the secondary A dash will be in this particular way. Now, here let us talk about the second phase, which is B dash. So if it is in this way, I can say that this is my B dash and B. See, this small b is along with this. The phase or the alignment is same. Okay, for the secondary. Similarly, C, alignment of C phase is in this way. So I can just draw my C phase in this way, which is C dash and C. Now what I am saying is, I am connecting A, B and C. So if I connect A, B and C, what will happen? That means I will connect this point and this point. So if I connect this point to this point and this point to this point, what will happen? You see. So what I will do is, since I have connected, I will just bring it here. Since I will bring it here, let me draw it here again. That means A dash A. So since I have connected, I can bring this particular connection here. That is, this is my B now, and this is my B dash. So I can draw it in this way. Similarly, I will connect this C point also to this A and B. That means what I will do is, I will bring this particular, I'll just slide it over here without changing the alignment. I will not change the alignment of that. So I can write it in this way. So this is, so this I have connected C also, so I will call this as neutral, and this is my C dash. Now you see, what is the what is the phase of E A dash N and E A N. So you see, both of them are in the same direction. Since both of them are in the same direction, that is vertically upwards, or if we can see in a clock also. Let us say this is a clock, and this is 12 o'clock, this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11. So this is my clock. Let us say the primary is drawn with blue ink. Let me represent the primary phasor by blue ink, and let me say that this primary is represented the minute hand. So say this is towards this 12, and this particular A dash, okay, EA dash is also along this direction, or this is secondary is my hour hand. So this is also along this. So I can say that in a watch, if it is represented, I will say that this is 12 o'clock. Or I can say in this way, primary I can represent by big Y, secondary by small y, and the phase difference between them is 0 degrees. So I can say that y is 0 or y 12. Same thing. 12, why? Because 12, it is 12 o'clock. So we'll understand that if it is 12 o'clock means the difference between the phase of the primary and the phase of the secondary is 0 degree, or there is no phase shift. So I can say that it's y 0 or y 12. Okay. So this is how to find out the phasor if I connect A, B and C. Now let us see what will happen if I connect A dash, B dash and C dash. So I will just modify it here itself and let me see what happens. Okay. So what I'm saying now is that I will be modifying this and I will connect A dash, B dash and C dash. So you see, now I will be connecting this A dash, B, B dash. So A dash, B dash and C dash. These are the 3 points which we will connect now. So what happens if I connect A dash to B dash? So say this is my this is the situation I can show where this is my A dash, this is my A, now this is my C dash, C dash, C, B dash. Okay. Now you see what happens is if I take the phasor, you see this is my now A phase. Okay, A phase in the primary, whereas in the B phase, the primary, in B phase, for the A phase in the secondary, it is in this direction, downward direction. So what I can say is, this is my primary A phase, E, A, and in the secondary, what is happening is, this is along this side, E, A, okay? Yeah, this A phase, the angle between them is 180 degree, and I can say that it is 6 o'clock. The second hand or the secondary phase will be along 6, so I can say it is 6 o'clock. So I can represent this as YY6. Okay? So this is the second possible connection. Now you see there, I may say, or we may think that we may connect in some other way also. That means why not connect A, B and C dash. So why not connect A, B and C dash? So this is the third connection. Now let us see if it is possible or not. The first criteria of connecting is that my secondary phasor or the phase difference between the secondary, okay, the phase difference should be 120 degree. So if I connect, say, A to B, so what will happen if I connect A to B means this is B, this is my A dash, this is my A. Now I'm connecting, say, this is my A dash and this is my A. Now I'm connecting A to B. So that means this is my B. So this is my B and this is B dash. Now what I'm doing is I'm connecting C dash to B. If I do that, you see, if I do that, the C dash will be in this way. So you see now, the phase difference, now this is my A phase, now this becomes neutral. Now this becomes neutral, this is my EA, this is my EB of secondary, and this is my EC of secondary. Now you see the phase difference between them is 60 degree, not 120 degree. So this particular connection is not possible. That is the reason we don't connect it in this way. And we cannot also connect, say, A dash, B dash, and C, or A, B dash, C. These connections are not possible. So the only two possible connections are either I will connect A, B, and C, or I will connect A dash, B dash, and C dash. Now, what is the, how will you figure out which side to connect if the names are not given? You see, I will connect those sides which are having a similar dot convention. Say these three windings have similar dot conventions. So I can connect all these 3 points, or the points which are opposite side to the dot convention. That means A dash, B dash, and C dash. Okay. So that is how we need to connect this particular thing. Now let us see what happens in star delta case. Let us take the delta case, which is even more important. So we have seen the star case. Now let us see the star delta case. Now you see, say this are my windings. Let me say this is A dash, A, B dash, B, C dash, C. Okay. Now, how can I connect in star? So star connection, you see it can be done in this way. This will be B. I can connect A dash with B, B dash with C, and C dash with A. And the output I can take away from these 3 points. So this becomes my first connection of delta. That means I am connecting A dash. I am connecting A dash with B. Okay. I am connecting A dash with B. So since I am connecting A dash with B, I will maintain the symmetry and I will connect B dash with C and C dash with A. So in this way, this is my connection. So let me write it out. So I can say this is B dash with C and C dash with A. Now, how can I show it in phasors? So let me draw the phasor now. So again, similar concept. Similar concept means what I will do is, see, my secondary phasors will be in this way, which will not have any change. That means this is my A dash A, this is my B, B dash, and this is my C dash C. Now what I am saying is I am connecting A dash to B. So this is my A dash and A, and now I am connecting A dash to B. That means this and this. So what will happen is this is my B and this is my B dash, and I am connecting B dash to C. So if I am connecting B dash to C means my C alignment of C is in this direction, so it will be in this direction, and I am connecting C dash to A also. So this is my connection now. Now let me find out what is the phase difference between the primary and the secondary. So say this is my secondary and this is my primary, and let me find out the phase difference. So you see, as I have said that I took the output points as I have shown earlier, I have taken the output points, let's say at A dash, B dash, and C dash. So let's say these are my output points, or I will mark it with some other ink. That means these are my output points. This one, and this one. And this is say A, and secondary B and secondary C. Okay? Now, what is the neutral point here? We know the neutral point will be the centroid of this particular triangle. So what we will do is we will connect here to this centroid, and this is an equilateral triangle. Okay, since we have considered the number of turns in all the phases will have the same ratio, so the EMF induced in all the secondary phases will have the same value. So this will be a centroid. So if this is centroid, this point will be neutral. So if this point is neutral, so I can say that this is my E, A, N, or let me write it in small. This is my secondary EAN, secondary A phase. So let me see, where is my primary A phase? So you see, this is the neutral point of the primary, and this is where my primary A phase is. So if this is my primary A phase, so how can I show it in this? This is vertically straight. So this is where my primary A phase is. This point is A dash. And this point is small a dash. Let me say this is just primary E, A, N. Or you can say dash, you can also give the dash also. Doesn't matter. So this is my E, A dash, N, and this is my secondary E, A dash, N. And you see, if you try to calculate the angle between them, so this is 90 degree, and this particular angle I know is 120 degree. So this is 120, this is 90. So the angle between them is 120 minus 90, which is 30 degree. So this is 30 degree. So I can say that, you see, the phase difference between the phases of primary and secondary has changed. Whereas in star-star connection, what we have seen is the difference between the phases of the primary and secondary is either it's 0 degree or it's 180 degree. Whereas what happened here is the primary is lagging the secondary, or the secondary is lagging the primary. Now, if we represent the primary as the minute hand and the secondary as the hour hand in a clock, so what will happen? Let us see what happened. Now you see, this is 30 degree. I know 30 degree will be along this 11. So you see, it is 11 o'clock. So since it is 11 o'clock, this particular diagram will be called as Y, capital Y for primary, small d for secondary, and 11 since the angle between them is 11 into 30 degree, which is 330 degree. So I can say that my secondary is lagging primary by 330 degree, which is 11 into 30, 330 degree. Or my secondary is leading primary by 30 degree. I can say any of them. Okay, I can say anything. So leading by 30 degree and lagging by 330 degree is the same thing. If we go clockwise, we say that we are lagging. Okay, if we go anti-clockwise, we calculate the angle, whatever angle it comes, we say that we are leading. Okay, so you see, we went here anti-clockwise and we have found that it is 30 degree. In this way we have went 330 degree clockwise. So we are saying that my secondary is lagging the primary by 330 degree. Okay, so these are all the same thing. Okay, so by connecting A dash to B, what I have seen is that I am getting a phase difference of 30 degree, which is lagging. Okay, that means my primary is lagging. So let us see what happens with some other connection. What else connection is possible? So what I can do is I can connect A dash to C also. Okay, what I can do is, second connection is I can connect A dash to C. That means, let us redraw it and see what else can be the connection. That means, see, this is A dash, this is A, this is B dash, this is, sorry, this will be this side, let this side be the dash. C dash. So now what we can do is, we can connect, say, A dash to B, B dash, or we can connect A to B dash, B to C dash, and C to A dash. So let us see what happens if we connect in this particular way. Okay, so what I'm saying is, we'll connect A dash to C this time. So if I connect A dash to C, means this is my A dash, this is my A dash, and this is my A. Now I'm connecting A dash to C this time. Okay, so if I'm connecting that to C, what will happen is, this is C. See it, if you understand it once time, you don't have to, reiterate this thing. You can directly draw out by looking at this particular thing. Okay, so C dash, this is C dash, so I have to write it in C dash. This is B dash, so I'll be writing it as B dash, as simple as that. Okay, now you see, where is my neutral? This is my neutral point. I will connect this to the neutral, and since this is my A dash point, so here is where I am taking my output. So if this point I am taking my output, so I can just say this is my A dash end point. So this is my neutral. Okay, but I also know that my primary is vertically in this way. So my primary is along this way, which is EAN, and the angle between them you see is now again 30 degree. If you see, this is 90 degree, or you can say this is an equilateral triangle and the angle between them is 30 degree. Okay, so in this way you can see that it's a very simple calculation. Okay, that this is 30 degree. That means now the case is different. Now you see, my secondary phase voltage is lagging the primary by 30 degree. So I can say that if I see in the watch, now my secondary is lagging. That means my secondary is in this side. So I hope you will understand why it is now, or what is the time of the watch now. So the time of the watch or the clock will now be 1 o'clock. So I represent this particular connection as Y capital, D small, and 1. Or in other words, when I say 1 means I have to multiply 1 with 30 degree, and when I say 30 degree means my secondary is lagging the primary phase by 30 degree. When I write 11, I have to multiply 11 with 30, so it becomes 330 degree. That means my secondary voltage, phase voltage, or any vector, okay, or any vector. So my secondary phase of any vector will lag the similar primary phase by 330 degree. That's what we mean when we write this 1 or 11. Okay. Now, if we take, so these are the two possible connections you see. What happens if we take some connection which is outside this? That means what happens if we connect say A dash to B dash and then C, okay, or C with something else. So if I connect A dash to B dash, what happens? So if I connect, say, so what happens if I connect A dash to B dash? Let us draw it again. So what I have already mentioned is, whatever way I connect, my secondary phase difference should be 120 degree. I cannot disturb that particular thing. So now I know this is my A dash and A. Now if I am connecting A dash to B dash, what happens is this particular thing, I am connecting B dash. Now I am connecting A dash to B dash, and let us say I am connecting A to say C dash. So if I connect A to C dash, so it will be something like that. Or if I connect A to C, it will be something like that. And now, so this is C and this is C dash, and I am connecting B to C dash. That means the connection is something like that. A dash to B dash, A to A with C, and C dash with B. C dash with B. So if I connect in this way, you see the phasor between the secondary is not 120 degree, or the phase difference in the secondary is not 120 degree. Okay, so since it is not 120 degree, I cannot consider this particular connection, or rather any connection out of this particular two connections is not possible. That means what I can do is, so what is the summary? The summary, let us understand the summary. So let us understand the summary. So let me say that this point is A dash, B dash, C dash. So what happens is, if I connect A dash to B dash to C, and C dash to A, then what I will get is, I will get this particular YD11. Similarly, if I connect again same connection, same meanings, different connection. So let us say this time I'll connect A with B dash, B with C dash, C with A dash. So C with A dash. So what happens here is, I'm taking output at this particular 3 points. Similarly, I will take output at this particular 3 points. So in both the cases, what we have seen is, in this case we will get YD11, in this case we will get YD. So this is how, you see, we can calculate. So this is the possible connections that we have seen. Now let us go back to the problem, or the gate problem which was given, and let us see whether we can solve that particular question with what we have learned. Whatever we have learned till now, we can also apply the same particular thing for delta connection and delta star connection. Delta star connection. Okay, as I have already said that delta connections will be two possible connections, DD1 and DD0 and DD6. Okay, that means 0 degree or 180 degree difference will be there. And delta star connection, there will be two possible ways, delta star 1 or delta star 11. When I say 1, I am repeating it again. Whenever I will have delta star 1, it means that my secondary phase will be lagging by 30 degree with respect to the primary. If it is 11, that means it is leading, or my secondary is leading by 30 degree to the primary, or lagging by 330 degree. Okay, leading by 30 degree or lagging by 330 degree. So this is the summary. Now let us solve the gate question. So if you remember the GATE question, it was So if you remember, this was the question, and the points as given in the question, this is a 2016 question, and this is the neutral point, these are the dot conventions which are given, and this point is B and this point is C, whereas this point is given as A, this point is given as C, and this point is given as B, and the dot conventions given are in this way. And now the question is, what is the phase difference between V, A, B and V, A, B? That means the phase difference between the line voltages, okay, of primary and secondary. So you see, let us draw it, okay. So if you draw, as we have learned, what we have learned is, we will name the, so the first thing that we will do is, we will name the windings. So this point is A, so let me name this winding as A here and say A dash here. Similarly, C is the name of this particular point, so C dash here. Similarly, B dash here and B here. Okay, doesn't matter with what you name. You may name it as A1, A2, you may name it as A dash, or you may name it as A dash, A, whatever it is, doesn't matter. Okay, it's just convention. So, you see, now this particular, by looking at this, you can say, what is the VAB? If you see VAB, this is my VAB. Okay. Now, how to find out the VAB here? See, this point is A. If this point is A, now you may think which point is my A dash. That means this particular point. If this is A, I know this is A. If this is C, I know this is small c. If this is B is given here. So since this is B, I know this is B. But which point is my A dash? Is this my A dash or this my A dash? Now I'll always say that since the alignment is not going to change. So you see the alignment here of A dash is matching this, not this. So this will be my A dash. So this is the catch of this particular question. If you can understand that this point is my A dash, similarly this point is my B dash, and this point is my C dash, the question is solved. That means now I can easily say that my AB angle, so see, I knew this is B and this is A, so I can say easily that this is my VAB. Okay? So if this is my VAB, so if say this is my VAB means this is my, is along the same winding, along this. So this is my V small a small b. So easily I can say that my V small a small b or V secondary. So my secondary line voltage, you see this is my secondary blue one, this is my secondary line voltage, which is leading the line voltage of the primary, or I can say my primary line voltage is lagging by how much angle? So I need to find out this angle. So how to calculate this angle? You see, this is an equilateral triangle, and I know equilateral triangle, this will be 60 degree. So half of this, so this this is equal to this. So if this is 60, this is half of this is 30. So this 30 means this will also be 30 degrees. So I can say that VAB lags V small v by 30 degree. So this is the answer of the particular question. So there will be 4 options. Out of the 4 options, this will be the answer. Okay, that's it. So what we will do is we'll take one more example which is of 2015 and we'll try to solve that question. So this is a 2015 question. Let me draw the question. So it is said that there are two parallel transformers here. So you see this is one set of transformer and this is other set of transformer. Now these are parallel transformer and the connection of this transformer is in such a way. This primary side is delta connected. Okay. Primary side is delta connected. So you see, this side connection is similar. This connection is similar to this connection. Whereas the secondary of both the transformers which are in parallel are differently connected. That means the connection here is in this way. Okay. And the connection in the second transformer is this way. That means this secondary of the first transformer is delta connected, whereas the secondary of the second transformer in parallel is star connected. Now what the question is, say this is my voltage V1 and say this is my voltage V2. Now they are asking what is the phase difference, and this is a numerical type question. That means the fill in the blanks, and the fill in the blanks what will you feel is what's the phase difference between V1 and V2. Okay, now the thing is how to solve this particular question. So what we will do is very simple. Whatever we have learned we will apply. That means let us draw the phasor of the primary and see it is this particular what is V1? You see V1 is nothing but VA2 P2. okay, of first transformer. And what is B2? V2 is nothing but VA2 B2 of VA2 or line voltage VA2 B2 of the second transformer. So we need to find out the line voltage. So what we will do is, first of all, we will draw the phases of both the transformers. You see, let us say the first side is delta connected. So since that is delta connected, so let us take it in this way. Let me draw it properly. Say this is the delta connection. Okay, this. Now let me say that this is say A2, A1. Now I have connected A1 with B2. Okay, so let me say this is B2 and say this is B1, and I have connected B1 with C2. So that means this is C2, and I have connected C1 with A2. So I have connected C1 with A2. So this is the connection of the primary in both the cases. So both the cases are having the same connection. Okay. So now let us see what is the connection in the secondary. Okay, in the secondary, let us see. In the first transformer, let us draw it with some other color. That is first transformer secondary. I have connected A1 with B2. So you see this is my A2 A1. Now what I am saying is I am not going to change the alignment again. So see, this is my A2 A1 and I am connecting A1 with B2. So if I am connecting A1 with B2, so that means this, and I am connecting C2 with B1. C2 with B1, that means this is similar, or in other words I can say this first transformer secondary has a similar or 0-degree connection, okay, with respect to the primary. Okay, so you see this is my VA2, B2, or this is, let me draw with the red one for the secondary. Okay, let me first mark it out. So you see, this is the angle of this particular V1. So I can say this is my V1. Okay, this is my V1. I'm just drawing, I can draw it anywhere. I am drawing this particular V1 in the primary itself. Now, let me point out, or let me draw the second one. So the second one I'll draw with red color. So you can see what I'm doing here is I'm connecting A1, B1 and C1. So the first thing is, this is my A2, A1, and now I'm connecting it with B1. That means this is my B1, B2, so it will be along in this direction, B1, B2, and this is my C1, C2, so C1, C2 will be along this one, C1, C2. Now I need the angle between A2 and B2. So A2 and B2 means this, now see, this triangle is a equilateral triangle, and I know this is my B2 point. So this is my V2. So if this is my V2, the angle between this vertical line, which is nothing but my V1, as I know that this V1 is a vertical line. So this is my V1 and this is my V2. And let me calculate this angle. I know this complete angle is 60 degree since this is a equilateral triangle. So half of this is 30 degrees. So this angle is going to be 30 degree. And I can say that phase difference between them is 30 degree. Or if it comes in options, this particular answer will be 30. So it's solved. So phase difference between V2 and V1 will be 30. Now let us see which is leading and which is lagging. So by looking at this, I can say that V2 is lagging V1 by 30 degree, or in other words, V1 is leading V2 by 30 degree. Okay. So you see, you can expect any types of questions on this particular concept of phases. Okay. So it will be very, very helpful. I hope it will be very, very helpful for you by looking at this lecture and learning how to draw the phases for the three-phase transformer. With this, I conclude my topic. Thank you.